Now, in this lecture, we'll find out the length of line segment X using three different methods. In the drawing, we have the right triangle ABC. We know that side AB of triangle ABC equals to 6 units. We also know that side DC equals to 10 units. Angle ABC equals to 90 degrees. Angle DAC equals to 45 degrees. And we want to find out the value of line segment AD that is equal to X. So we'll start with the first method, and here we'll make a construction. We will extend line segment AD by a straight line, and from point C we will draw perpendicular to the extended AD. So this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. We will define the touching point of the perpendicular from point C and the extended AD as point E. So we'll focus on the right triangle AEC. On this right triangle AEC, we know that the sum of the angles must be equal to 180 degrees. So which angles we have in the right triangle AEC? We have here one angle that is equal to 45 degrees, and we have this angle that is equal to 90 degrees according to our construction, and we have the missing angle that is actually angle ACE. Angle ACE. In total, the sum of those three angles must be equal to 180 degrees according to the rule that the sum of the angles in any triangle is equal to 180 degrees. We will subtract 135 degrees from this equation, and we will get that the missing angle, angle ACE, is equal to 180 degrees minus 135 degrees is 45 degrees. Okay, so this angle ACE equals to 45 degrees. And we also know that in front of equal angles in the triangle there are equal sides. First of all, we define line segment DE as Y, and we have the rule that in front of equal angles in the triangle there are equal sides. So in front of those two equal angles in triangle AEC, we have equal sides. That is to say, AE must be equal to EC. AE must be equal to EC according to the rule that I mentioned, but AE equals to X plus Y. So from this equation, X plus Y equals to AE equals to EC, we will derive that EC is also equals to X plus Y. EC is also equals to X plus Y. EC equals to X plus Y. And we also, those two angles are defined as vertex angles, and we know that vertex angles are equal to each other. So if we define this angle as alpha, then this angle must be also equal to alpha because of the fact that those two angles are equal to each other. And in the right triangle ABD, this angle equals to alpha. So this angle BAD must be equal to 90 degrees minus alpha in order to complete the sum of the angles in triangle ABD to 180 degrees. Here we get that 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees. Likewise, from the same reason, in the right triangle DEC, this angle equals to alpha, so this angle must be equal to 90 degrees minus alpha. So here we actually proved that those two right triangles are similar to each other. Why? Because they have exactly the same angles. Those two angles are both equal to 90 degrees minus alpha, those two angles are both equal to alpha, and those two angles are both equal to 90 degrees. So we actually proved that the right triangle ABD is similar to the right triangle EDC, according to angle similarity rule. So I will write it down. We have the right triangle ABD, the right green triangle, and the right green triangle EDC. So those two angles are equal to each other. That is to say, angle BAD in triangle ABD is equal to angle EDC, and both angles are equal to 90 degrees minus alpha. I repeat again. In the right triangle ABD, angle BAD is equal to angle ADC, and both angles are equal to 90 degrees minus alpha. Likewise, those two angles are equal to each other, also equal to each other, they are equal to alpha, so angle BDA is equal to angle EDC, and both angles are equal to alpha. Angle BDA is equal to angle EDC, and both angles are equal to alpha. And finally, those two angles are also equal to each other, they are equal to 90 degrees. So angle ABD is equal to angle EDC is equal to angle DEC, this angle, and both angles are equal to 90 degrees. I repeat again, angle ABD is equal to angle DEC, and both angles are equal to 90 degrees. So we prove that all three angles in triangle ABD can go into all three angles in triangle ADC. Therefore, we proved that the right green triangle ABC is similar to the right green triangle EDC. The right green triangle ABD is similar, this is the sign of similar, to the right green triangle EDC, according to angle similarity rule. Okay, and from the fact that triangle ABD is similar to triangle ADC, we conclude that AB over EC is equal to BD over DE, and it is equal to AD over DC. I'll repeat again. From the fact that triangle ABD is similar to triangle EDC, we conclude that AB over EC equals to BD over DE, and it is equal to AD over DC. Okay. So here AB is equal to 6 units, so we substitute AB by 6. EC equals to x plus y, so we substitute EC by x plus y. And it is equal to BD over DE. DE equals to y according to our definition. And it is equal to AD. AD equals to x according to what is given us in the question, over DC. DC is equal to 10 units according to what is given us in the question. So in conclusion, we found out that according to equation number 1, 6 over x plus y is equal to BD over y, and it is equal to x over 10. We'll find out the value of side BD by implementing the Pythagoras theorem on the green right triangle, triangle ABD. In the green right triangle, triangle ABD, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the square of the perpendiculars. The hypotenuse is AD, so the square of the hypotenuse is AD square. And it is equal to the sum of the squares of the perpendiculars, that is to say, is equal to AB square plus BD square. I repeat again. In the right triangle, triangle ABD, according to the Pythagoras theorem, PT is evolution from Pythagoras theorem, AD square equals to AB square plus BD square. AD is equal to x, so AD square is x square, and it is equal to AB square. AD equals to 6, so AD square is 6 squared, that is 36, plus BD square is the missing line segment, so we leave it as it is. So here we'll subtract 36 from this equation, and we'll get that BD square is equals to x squared minus 36. We'll take a root out of this equation, and we'll get that BD is equal to the square root of x squared minus 36. Okay, so we can substitute BD in equation number 1 by square root of x squared minus 36. We'll do it now, and we get that according to equation number 1. Six over x plus y, it is equal to BD, and we found out that BD equals to square root of x squared minus 36 over y, and it is equal to x over 10. So here we create two equations from this long equation, equation number 1. The first equation will be those two sides are equal to each other, so we can write down that according to equation number 1, 6 over x plus y is equal to x over 10. Here we'll cross multiply this equation, equation number 1, and we get that according to equation number 1, 6 times 10 is 60, and it is equal to x times x plus y. We'll open the brackets on this side of equation number 1, and we get that according to equation number 1, 60 equals to x squared plus xy. We will subtract 60 from this equation, equation number 1. And we will get that x squared minus x squared equals to xy. So according to equation number 1, we found out that x squared, 60 minus x squared equals to xy. In the next step we create a second equation from this long equation. Those two sides are equal to each other, so we can write down that according to equation number 2, square root of x squared plus 36 over y is equal to x over 10. Here we will cross multiply this equation, equation number 2, and we will get that according to equation number 2, xy, it is equal to 10 times the square root of x squared plus 36. In the next step, we will create equation number 3 that states that xy according to equation number 1 must be equal to xy according to equation number 2. So xy according to equation number 1 is 60 minus x squared, and it must be equal to xy according to equation number 2, that is actually 10 times square root of x squared minus 36. Here we will square both sides of equation number 3, and we get that according to equation number 3, 60 minus x squared equals to 10 squared, that is 100, times here the square will cancel the root, and we left only with x squared minus 36. So here we'll open the brackets on both sides of equation number 3, and we'll get that according to equation number 3, 60 squared is 3600 plus x squared is x to the power of 4 minus 2 times 60 times x squared, it is equal to 100 times x squared minus 3600. Here we will add 3600 to this equation number 3, and we get that 3600 plus 3600 is 7200, plus x to the power of 4, minus 2 times 60 is minus 120 x squared, and it is equal to 100 x squared. Here we'll subtract 100 x squared from this equation number 3, and we will get that x to the power of 4 minus 120 minus 100 is minus 220 x squared plus 7200 equals to 0. Here we'll substitute minus 220 x squared by minus 180 x squared minus 40 x squared. And we get that according to equation number 3, x squared minus 180 x squared minus 40 x squared plus 7200 equals to 0. Here we divide this expression to two parts, and we will take a common factor from each part. From those two expressions, we will take x squared as a common factor, and what is left from x to the power of 4 after we took x squared as a common factor, what is left? It is actually x squared. What is left from minus 180 x squared after we took x squared as a common factor? What is left? It is actually minus 180. Likewise, from those two expressions, we will take minus 40 as a common factor. What is left from minus 40 x squared after we took from it minus 40 as a common factor? What is left? It is actually x squared. What is left from 7200 after we took from it minus 40 as a common factor? What is left? It is actually minus 180, and it is equal to 0. Here, from here we take x squared minus 180 as a common factor, and we get that according to equation number 3, so x squared minus 180 is a common factor, so inside the brackets we have what is left from this expression after we took from it x squared minus 180 is a common factor. What is left? It is actually x squared. And what is left from this expression after we took from it x squared minus 180 is a common factor? What is left? It is actually minus 40, and it is equal to 0. So here we will have two solutions that are possible for x. The first solution for x is x squared minus 180 equals to 0. And the second solution for x is that x squared minus 40 equals to 0. So according to the first solution, x squared is equal to 180. 180 is 36 times 5. We take out of this equation number 1, and we get that the value of x according to equation number 1 is equal to the square root of 36 times 5. The square root of 36 is 6, and only 5 is inside the root. So we found out that according to the first solution for x, x will be equal to 6 times square root of 5 units. That is actually equals to 13.41 units. That is greater than 10 units. This is the first solution for x. And the second solution for x is that x squared equals to 40. We take a root out of this equation number 2, and we get that according to equation number 2, x equals to the square root of 40. 40 is 4 times 10. The square root of 4 is 2. So in conclusion, we found out that according to the second solution, x equals to 2 times square root of 10, that is actually equals to 6.32 units, that is less than 10 units. So those are the two solutions for x. In the next step, I will draw the right triangle ABD and the right triangle ADC in a new page, and we'll find out which solution is correct in our specific drawing. So here we'll have the right triangle ABD. We will define angle BAD as theta. This angle equals to alpha. So this is the right triangle ABD. This right triangle ABD, it has three interior angles that are theta, 90 degrees, and alpha. And the right triangle ABD is also one exterior angle that is actually angle ADC. This angle ADC is an exterior angle of the right triangle ABD. Okay. So I will write it down. Angle ADC is an exterior angle of the right triangle ABD. Okay. And we have a rule number 1, that determines what is the size of an exterior angle in a triangle, of a triangle. According to rule number 1, an exterior angle of a triangle is equal in its size to the sum of the two interior angles that are not adjacent to it. So I read rule number 1 again. According to rule number 1, an exterior angle of a triangle is equal in size to the sum of the two interior angles that are not adjacent to it. So here, according to this rule number 1, the size of this exterior angle ADC will be equal to the sum of the two interior angles that are not adjacent to it. Here, this angle alpha, is adjacent to angle ADC, therefore the other two interior angles that are not adjacent to it are theta and 90 degrees. And the sum of those two angles is 90 degrees plus theta. That is to say, the size of angle ADC, the exterior angle ADC, equals to 90 degrees plus theta according to rule number 1. Okay? And we also know that the sum of the angles in any triangle is equal to 180 degrees, and especially in triangle ADC, the sum of its angles must be equal to 180 degrees. So which angles we have inside triangle ADC? We have one angle that is equal to 45 degrees, and we have this angle that is equal, the exterior angle that is equal to 90 degrees plus theta, and we have the third angle that is actually the missing angle, angle ACD. Angle ACD, in total the sum of those three angles must be equal to 180 degrees, according to this rule that the sum of the angles in any triangle is equal to 180 degrees. So here we will subtract 135 degrees from this equation, and we get that angle theta plus angle ACD, they are equal to 180 degrees minus 135 degrees, it is 45 degrees. Here we'll subtract theta from this equation, and we'll get that the missing angle, angle ACD, is equal to 45 degrees minus theta. Okay, so we found out that this angle, angle ACD, equals to 45 degrees minus theta, And here it is very easy to see from the drawing that this angle ACD, that is one of the three angles of triangle ADC, is the smallest angle in triangle ADC. So we can write down that angle ACD, that is equal to 45 degrees minus theta, is the smallest angle in triangle ACD. Okay, and we have also rule number 2 that is related to the smallest angle in a triangle. According to rule number 2, the smallest angle in a triangle is always opposite to the shortest side. Repeat on rule number 2 again. According to rule number 2, the smallest angle in a triangle is always opposite to the shortest side. So here, according to rule number 2, this angle ACD, that is equal to 45 degrees minus theta, it is located, this AD equals to X, it is located opposite the shortest side, that is to say, according to rule number 2, AD that is equal to X, it is the shortest side. AD that is equal to X is the shortest side in triangle ADC. And especially AD must be less than DC. AD that is equal to X, it must be less than side DC of triangle ADC because it is the shortest side. And DC equals to 10 units. So from this equation we will derive that AD that is equal to, from this inequality we will derive that AD that is equal to X is less than 10 units, so X is less than 10 units. Okay, and we actually add two solutions for X. The first solution for X is that X equals to 6 times square root of 5, that is actually equals to 13.41, is greater than 10. So this solution, that X is greater than 10 units, is incorrect solution. We will cancel this solution because it is greater than 10 and X must be less than 10. units, and we left only with the solution that x is equal to 2 times square root of 10 units. That is actually equal to 6.32 units. This is less than 10 units. So the answer to the question is that the value of line segment AD that is equal to x, or the length of line segment AD that is equal to x, it is either equals to 2 times square root of 10 units, so we can present it as 6.32 units. We finished with the first method. In the next step, I will present to you how to find out the value of line segment AD that is equal to x according to the second method. Okay. In the second method, we will do another construction. This is point D. This is A, B, and this is C. So in the second method, we will do another construction. From point D, we will do a straight line on AC in such a way that the angle that will be created will be equal to 45 degrees. If the touching point is point E, then according to our construction, angle AED equals to 45 degrees. So, in the right triangle ADE, we have two equal angles. Both those two angles are equal to 45 degrees, and we know that in front of equal angles in the triangle there are equal sides. That is to say, according to the rule that I mentioned, AD must be equal to DE. AD must be equal to DE. But AD equals to x, it is given as the equation. So from this equation we will derive that x equals to AD equals to DE, we will derive that DE is also equals to x. Okay, here DE equals to x. And we also know that the sum of the angles in triangle ADE must be equal to 180 degrees. That is to say, which angles we have in triangle ADE? We have one angle that is 45 degrees, and we have the second angle that is 45 degrees also, and we have the missing angle that is angle ADE. In total, the sum of those three angles must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle in the world is equal to 180 degrees. 45 degrees plus 45 degrees is 90 degrees. We will subtract 90 degrees from this equation, and we write that angle ADE equals to 180 degrees minus 90 degrees, it is 90 degrees. So we found out that the missing angle ADE, is the right angle, it is equal to 90 degrees. Okay, so here, this angle is the right angle, it equals to 90 degrees. In the next step, we will define angle BAD as theta. So in the right triangle, triangle ABD, angle BAD equals to theta. So the missing angle BDA, must be equal to 90 degrees minus theta in order to complete the sum of the angles in triangle ABD to 180 degrees. So here, 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees. And we know that triangle ABC is a right triangle, therefore BC is one side of triangle ABC, therefore it is absolutely a straight line. BC is one side of triangle ABC, it must be a straight line. I will write it down. Line segment BC is a straight line. And we have the rule that says that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of the straight line BC at point D, then the sum of the angles must be equal to 180 degrees. So at the upper side of the straight line BC, at point D, the sum of the angles must be equal to 180 degrees. So which angles we have at the upper side of BC here at point D? We have here one angle that is equal to 90 degrees minus theta. We have also this angle that is equal to 90 degrees, and we have the missing angle that is angle EDC. This angle EDC. In total, the sum of those three angles must be equal to 180 degrees according to the rule that I mentioned, that the sum of the angles on one side of a straight line is equal to 180 degrees. So here we have 90 degrees plus 90 degrees is 180 degrees. So we have 180 degrees on both sides of the equation, so 180 degrees will get cancelled, and we are left only with minus theta plus angle EDC that is equal to 0. Here we will add theta to this equation, and we will get that the missing angle EDC equals to theta. If I know that this angle equals to theta, in the next step we will make another construction. From point E we will go perpendicular on BC. So this angle equals to 90 degrees, and this angle also will be equal to 90 degrees according to our construction. So in the right triangle, we will define the touching point of the perpendicular from point E and BC as F. So in the right triangle, triangle EFD, in order to complete the sum of the angles to 180 degrees, if this angle equals to theta, then this angle must be equal to 90 degrees minus theta. Okay. In the next step, we'll prove that those two right triangles can go into each other. They actually can go into each other according to angle side angle rule, and we'll prove it. So we'll focus on the right triangle, triangle ABD. Right triangle ABD. And the right triangle, triangle EDF. Why those two right triangles can go into each other? First of all, those two angles are equal to each other, they are both equal to theta. So angle BAD is equal to angle EDF and they are both equal to theta. I repeat again, angle BAD equals to angle EDF and they are both equal to theta. We also know that side AD of triangle ABD is equal to side DE of triangle DEF and they are both equal to x. So AD is equal to DE is equal to x. I repeat again. AD is equal to DE equals to x. And those two angles are also equal to each other. They are both equal to 90 degrees minus theta. So angle ADB, this angle, is equal to this angle, this is actually angle DEF, and they are both equal to 90 degrees minus theta. I'll repeat again, angle ADB is equal to angle DEF and both angles are equal to 90 degrees minus theta, so we proved that the two right-hand triangles can go to each other according to angle side angle rule. Here, those two angles and the angle and the side that is between them correspondingly can go to those two angles and the side that is included between those two angles in this right-hand triangle. Therefore, those two triangles can go to each other according to angle side angle rule. So I write it down. Actually, triangle ABD is congruent. This is the sign of congruent to triangle DEF according to angle side angle rule. And from the fact that those two right-hand triangles can go into each other, we conclude that AB equals to DF. Hence, AB equals to DF. According to the rule that corresponding sides and congruent triangles are equal to each other. But AB equals to 6. From this equation, 6 equals to AB equals to DF, we will derive that DF is also equals to 6. DF is also equals to 6 units. From the drawing, it is very easy to see that FC equals to DC minus DF. DC minus DF is equal to FC. That is to say, FC equals to DC, that is 10 units, minus DF, that is 6 units. So FC equals to 10 minus 6, that is 4. FC equals to 4 units. We write here that FC equals to 4 units. Likewise, because of the fact that those two green triangles can go into each other, we will conclude that BD is equal to EF. BD is equal to EF according to the rule that corresponding sides of congruent triangles are equal to each other. So if we define BD as Y, here BD is equal to Y according to our definition, then, so here I know that BD equals to Y according to our definition. So from this equation, Y equals to BD equals to EF, we will derive that EF is also equals to Y. So here EF equals to Y In the next step, we'll prove that the right triangle ABC, the right big triangle ABC, is similar to the right small triangle, triangle EFC. So we'll focus on the right triangle, the right big triangle, triangle ABC, and the right small triangle, triangle EFC. And we'll prove that those two right triangles are similar to each other. Why they are similar to each other? First of all, those two angles are equal to each other, they are both equal to 90 degrees. So angle ABC of triangle ABC is equal to angle EFC of triangle EFC. And they are both equal to 90 degrees. I'll repeat again. Angle ABC equals to angle EFC, and they are both equal to 90 degrees. This angle is a common angle, it belongs to both triangles. So we can write down that angle ACB in triangle ABC is equal to angle ECF in triangle EFC, because it is a common angle, it belongs to both triangles. I'll repeat again, angle ACB is equal to angle ECF, it is a common angle, it is actually the same angle that belongs to both triangles. And finally, those two angles are also equal to each other according to third angle theorem. So here angle BAC is equal to angle FEC, and those two angles are equal to each other according to third angle theorem. I'll repeat again. Angle BAC equals to angle FEC according to third angle theorem. So what is third angle theorem? Third angle theorem states that if two angles in one triangle can congruent to two angles in another triangle, then the third pair of angles must also congruent. Why? Because it is complementary to 180 degrees. Okay, we proved that those two angles in the right triangle ABC correspondingly congruent to those two angles in the right triangle EFC. Therefore, the third pair of angles, that is to say, those two angles, must also congruent because they are complementary to 180 degrees. So we actually proved that all the angles in triangle ABC congruent to all the angles in triangle EFC. Therefore, we proved that those two triangles are similar to each other according to angle similarity rule. So I will write it down. Triangle ABC is similar, this is the sign of similar, to triangle DEF according to angle similarity rule. And from the fact that triangle ABC is similar to triangle FEFC, we will derive that AB over BC is equal to EF over FC. I'll repeat again. From the fact that triangle ABC is similar to triangle EFC, we derive that AB over BC equals to EF over FC. here AB is equal to 6 units, BC is equal to y plus 10, and it is equal to EF is equal to y over FC equals to 4. So in conclusion, we found out that according to equation number 1, 6 over y plus 10 equals to y over 4. Here we will cross multiply equation number 1, and we will get that according to equation number 1, 6 times 4 is 24. 24 is equal to y times y plus 10. We will open the brackets on those side, in this side of the equation number 1, and we will get that 24 is equal to y squared plus 10y. We will subtract 24 from this equation number 1, and we will get that according to equation number 1, we will have here a quadratic equation y squared plus 10y minus 10 is equal to 0. We have here a quadratic equation, and the general formula for quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X is equal to minus b plus minus square root of b squared minus 4 times ac over 2a. Okay. In our specific quadratic equation, the coefficient a is equal to 1, the coefficient b is equal to 10, and the coefficient c is equal to minus 24 actually. Here we have minus 24 because we subtracted 24 from equation number 1, so we got here minus 24. So here c equals to minus 24, and the variable that we are looking for is y, so x equals to y. So we'll put the data inside the formula for x, and we find out the value of the values of y because x equals to y. So we get that y equals to minus b. B is 10, so minus b is minus 10, plus minus square root of b squared. B is 10, so b squared is 10 squared, that is 100. Minus 4 times a is 1, c is minus 24 over 2a, a is 1, so 2 times 1 is 2. So we got here that y is equals to minus 10 plus minus 4 times minus 24 is plus 96. 96 plus 100 is 196 over 2. The square root of 196 is 14, so here we have two solutions that are possible for y. The first solution, here y equals to minus 10 plus minus 14 over 2. So the first solution for y is y1 equals to minus 10 minus 14 over 2. Minus 10 minus 14 is minus 24 over 2. So y1 equals to minus 12. But because of the fact that y is the length of side BD, it must be a positive number. Y is a length, therefore it must be a positive number. Therefore, y1 cannot be equal to minus 12, that is a negative number. Or, okay, so we cancel this solution. And we left only with the second solution, that y2 equals to minus 10 plus 14 over 2. y2 equals to 14 minus 10 is 4, 4 over 2 is 2. So we found out that y equals to 2, or y2 equals to 2. So in the next step, I will copy the right triangle, triangle ABD in the new page, and we will implement the Pythagoras theorem on the right green triangle, triangle ABD. Okay, so in the right green triangle, triangle ABD, the right triangle ABD, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say, AB squared plus BD squared equals to AD squared. AB is 6, so AB squared is 6 squared, this is 36, plus BD is 2, BD squared is 2 squared, this is 4, and it is equal to AD squared, AD is x, so AD squared is x squared. So x squared equals to 36 plus 4 is 40. Here we take out of this equation and we found out that x equals to the square root of 40. 40 is 4 times 10, and the square root of 4 is 2. So here we have the solution for x, that is equals to either 2 times square root of 10 units, or in terms of numbers, it equals to 6.32 units. We finished in the second method. In the next step, I will present to you how to find out the value of line segment x according to the third method. In the third method, we'll define angle BAD as theta, and we'll define side BD of the right triangle, triangle ABD as y. So in the right triangle, triangle ABD, tangent theta equals to BD over AB. BD equals to y according to our definition, AB equals to 6 according to what is given us in the question. So in conclusion, we found out that in the right triangle ABD, tangent theta equals to y over 6. In the next step, we will focus on the right big triangle, triangle ABC. In the right big triangle, triangle ABC, we know that here we know this angle is equals to 45 degrees. It is given us the question. So here, tangents theta plus 45 degrees in the right triangle ABC. It is equal to BC over AB. BC equals to y plus 10, and AB equals to 6. So in conclusion, we found out that in the right triangle, triangle ABC, tangents theta plus 45 degrees, this is equation number 1, is equal to y plus 10 over 6. Okay, so actually we have trigonometric identity for tangent theta plus 45 degrees. The value of tangent theta plus 45 degrees is equal to 1 plus tangent theta over 1 minus tangent theta. So we can substitute tangent theta plus 45 degrees in equation number 1 by this expression. We do it now, and we will get it according to this trigonometric identity. Tangent theta plus 45 degrees, it is equal to 1 plus tangent theta over 1 minus tangent theta. And according to equation number 1, it is equal to y plus 10 over 6. And then we already found out that tangent theta equals to y over 6, so we can substitute tangent theta in equation number 1 by y over 6. We'll do it now, and we'll get, according to equation number 1, one plus tangent theta is y over 6, over 1 minus tangent theta is y over 6, is equal to y plus 10 over 6. Here we will multiply 1 by 6, and then we will divide it by 6 in order to work a common factor with y over 6 and minus y over 6, and we will get that according to equation number 1, 6 plus y over 6 over 6 minus y over 6 equals to y plus 10 over 6. Here we have 6 in the numerator and 6 in the denominator, so 6 will get cancelled, and we're left only with 6 plus y over 6 minus y, that is equal to y plus 10 over 6. Here we'll cross multiply this equation number 1, and we'll get that according to equation number 1, 6 times 6 plus y equals to 6 minus y over times y plus 10. We'll open the brackets on both sides of this equation number 1, and we'll get that 6 times 6 is 36. 6 times y is 6y, plus 6y, plus 60, minus y squared, minus 10y. Here we have 6y in both sides of equation number 1, so 6y will get cancelled, and we're left only with, according to equation number 1, 36 equals to 60 minus y squared minus 10y. Here we will add y squared and 10y to this equation number 1, and we will get it according to equation number 1, y squared plus 10y, and here we will subtract 60 from this equation number 1, and 36 minus 60 is minus 24, it is equal to 0. So this quadratic equation, we solved this quadratic equation in the second method. We found out that here we will have two solutions that are possible for y. The first solution, y1, is equal to minus 12, and the second solution, y2, is equal to 2. Here, y1 cannot be equal to a negative number because of the fact that y is the length of one side of a triangle, therefore it must be a positive number, therefore it cannot be equal to minus 12. So we will cancel this solution, and we left only with the solution that y2 equals to 2. So here I will draw the right triangle ABD in this new page, and we will implement the Pythagoras theorem of the right triangle ABD. According to the Pythagoras theorem, in the right triangle ABD, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AD squared equals to AB squared plus BD squared. AD is x, so AD squared is x squared, and it is equal to AB squared, AB 6, so AB squared is 6 squared, it is 36, plus BD squared. BD is 2, so BD squared is 2 squared, it is 4. 36 plus 4 is 40. So we found out that x squared equals to 40. We take out of this equation and we found out that x equals to the square root of 40. That is actually equals to either 2 times square root of 10 units, so in terms of numbers it is equal to 6.32 units. Okay, we finished with the first method. In the next step I will summarize the lecture. Actually, we wanted to find out the value of line segment x that is actually AD is equal to x, and in order to find out the value of line segment AD that is equal to x, we made a construction here. We extended line segment AD by a straight line, and then from point C we drew a perpendicular to the extended AD. We defined the touching point between the perpendicular from point C and the extended AD as E. So this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. And here we have in the right triangle AEC, the sum of the angles must be equal to 180 degrees. So which angles we have in this right triangle AEC? We have one angle that is equal to 45 degrees, we have a second angle that is equal to 90 degrees, and we have the missing angle ACE. In total, the sum of those three angles must be equal to 180 degrees. So we subtracted 135 degrees from this equation, and we got that the missing angle ACE equals to 180 degrees minus 135 degrees. It is 45 degrees. So angle ACE equals to 45 degrees. So here we have in the right triangle ACE we have two equal angles, and we know that in front of equal angles in the triangle there are equal sides. That is to say, AE must be equal to EC. AE must be equal to EC. We define DE as y, so AE equals to x plus y. AE equals to x plus y, so from this equation x plus y equals to AE equals to EC, we'll derive that EC is also equals to x plus y. Then those two angles are defined as vertex angles, and vertex angles are equal to each other. So if this angle equals to alpha, then this angle must be also equal to alpha. In the right triangle ABD, this angle equals to alpha, so this angle must be equal to 90 degrees minus alpha in order to complete the sum of the angles in the right triangle ABD to 180 degrees. Here 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees. Likewise, for the same reason, in the right triangle DEC, this angle must be equal to 90 degrees minus alpha. This angle equals to alpha, so this angle must be equal to 90 degrees minus alpha in order to complete the sum of the angles to 180 degrees. Then we prove that those two green right triangles are similar to each other. Why those two green right triangles are similar to each other? First of all, those two angles are equal to each other, they are both equal to 90 degrees minus alpha. Those two angles are equal to each other, they are both equal to alpha, and those two angles they are also equal to each other, they are both right angles, they are equal to 90 degrees. So we proved that the right green triangle ABD is similar to the right green triangle DEC according to angle similarity rule. Okay, and from the fact that those two right green triangles are similar to each other, we will conclude that AB over EC equals to BD over DE equals to AD over DC. Okay? Again, AB over EC equals to BD over DE equals to AD over DC. AB equals to 6, EC equals to x plus y, BD is BD, and DE equals to y. AD equals to x, DC equals to 10. Then, in order to find out the value of side BD, we implemented the Pythagoras theorem on the right green triangle, triangle ABD. Here, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, in the right triangle ABD, AD square equals to AB square plus BD square. Again, in the right triangle ABD, according to the Pythagoras theorem, AD square equals to AB square plus BD square. AD is equal to x, so AD square is x square. AB equals to 6, so AB square is 6 squared, that is 36, plus BD squared, that is the missing line segment. We subtracted 36 from this equation and we got that BD square equals to x square minus 36. We took out of this equation and found out that BD equals to the square root of x square minus 36. Now we can substitute BD in this equation number 1 by square root of x square minus 36. We did it and we got that according to equation number 1, 6 over xy equals to BD, that is actually x square minus 36. BD is equal to the square root of x square minus 36, according to what we have already found out, over y equals to x over 10. Then from this long equation, we created two small equations. The first equation, those two sides are equal to each other. That is to say 6 over x plus y equals to x over 10. Because multiplied this equation number 1, and we got that 6 times 10 is 60, and 60 must be equal to x times x plus y. We open the brackets on this side of equation number 1, and we got that 60 equals to x times x is x squared plus xy. We subtracted x squared from this equation, and we got that according to equation number 1, x squared equals to 60 minus xy equals to 60 minus x squared. Then we created equation number 2 from this long equation. Those two lines are equal to each other, those two expressions, they are equal to each other. That is to say, square root of x squared minus 36 over y equals to x over 10. Because multiply this equation number 2, and we got that xy equals to 10 times square root of x squared minus 36. Then we created equation number 3 that states that xy according to equation number 1 must be equal to xy according to equation number 2. So xy according to equation number 1, it is equal to 60 minus x squared, and it must be equal to xy according to equation number 2, that is equal to x times square root of x squared minus 36. Then we squared both sides of equation number 3, and we got that 60 minus x squared equals to 10 squared, that is 100. And the square cancels the root, and we're left only with x squared minus 36 here. And then we open the brackets on both sides of equation number 3, and we got that 60 minus x squared equals to 60 squared, that is 3600, plus x squared, that is x to the power of 4, minus 2 times 60 times x squared, it is equal to 100 x squared minus 100 times 36, that is 3600. Then we added 3600 to this equation, and we got that 3600 plus 3600 is 7200, plus x to the power of 4 minus 260 is minus 120 x squared, and it is equal to 100 x squared. Here we subtracted 100 x squared from this equation, and we got that minus 120 x squared minus 100 x squared is minus 220 x squared, and we have also x squared plus 7200 that is equal to 0. Here we substituted minus 220 x squared by minus 180 x squared and minus 40 x squared, and we got that x squared minus 180 x squared minus 40 x squared plus 7200 equals to 0. So we divided this expression to two parts. The first part is x squared minus 180 x squared. We took x squared as a common factor. Inside the brackets we will have x squared minus 180, and from those two expressions we took minus 40 as a common factor, and inside the brackets we will have x squared minus 180. So from this expression we took x squared minus 180 as a common factor, and inside the brackets we have x squared minus 40. So here we will have two solutions that are possible for x. The first solution is x squared minus 180 equals to 0, and the second solution for x is x squared minus 40 equals to 0. According to the first solution, x squared equals to 180. 180 is 36 times 5. We took out of this equation number 1, and x equals to the square root of 36 times 5. The square root of 36 is 6. So in conclusion, we found out that according to equation number 1, x equals to 6 times square root of 5. That is actually 13.41, that is greater than 10. Then, according to the second solution, x squared equals to 40. We took out of this equation and we found out that x equals to the square root of 40. The square root of 40 is 10 times square root of 2 times square root of 10. So according to the second solution for x, x equals to 2 times square root of 10 units. So in terms of numbers, it is equal to 6.32 units, that is less than 10 units. Then, in order to find out which one of the two solutions is relevant to our drawing, I draw the right triangle ABD, and the right triangle and triangle ADC in this new page. Here, triangle ABD, the green right triangle, has three interior angles, that is theta 90 degrees and alpha, and one exterior angle, that is angle ADC. ADC is the exterior angle of the right triangle, triangle ABD. Okay, and we have rule number 1. According to rule number 1, the exterior angle of a triangle is equal in its size to the sum of the two interior angles that are not adjacent to it. So according to rule number 1, the value of the exterior angle ADC will be equal to the sum of the two interior angles that are not adjacent to it. Angle alpha is adjacent to angle ADC, therefore the other two interior angles that are not adjacent to it are theta and 90 degrees. Therefore, according to rule number 1, the size of the exterior angle ADC will be equal to the sum of the two interior angles, that is actually it will be equal to 90 degrees plus theta. Then we know that the sum of the angles in any triangle is equal to 180 degrees, and especially in triangle ADC, the sum of its angles must be equal to 180 degrees. So which angles we have in triangle ADC? We have one angle that is 45 degrees, the other angle is 90 degrees plus theta, and we have the missing angle that is angle ACD. In total, the sum of those two angles must be equal to 180 degrees. We subtracted 145 degrees from this equation, and we got that theta plus ACD equals to 180 degrees plus 135 degrees is 45 degrees. We subtract the theta from this equation and we found out that angle ACD, the missing angle, is equal to 45 degrees minus theta. You can see from the drawing that angle ACD that is equal to 45 degrees minus theta is the smallest angle in triangle ADC. Okay, then I presented to you rule number 2, according to rule number 2, the smallest angle in a triangle is always opposite the shortest side. So here we found out that angle ACD that is equal to 45 degrees minus theta is the smallest angle, and according to rule number 2, it must be in front of the shortest side, opposite the shortest side. That is to say, AD that is equal to X is the shortest side. Okay, AD that is equal to X is the shortest side according to rule number 2. AD is the shortest side of triangle ADC. So AD is the shortest side. That is to say, AD must be less than side DC, and DC equals to 10. AD that is equal to X must be less than DC, and DC equals to 10. That is to say, AD that is equal to X is less than 10. That is to say, X is less than 10 units. So X is less than 10 units. According to the first solution, we got that X equals to 6 times square root of 5 units. That is 13.41. 13.41 is greater than 10. So X is greater than 10 according to this solution, but X must be less than 10. So this solution is incorrect solution. We will cancel this solution, and we left only with the solution that X equals to 2 times square root of 10 units, that is 6.32, that is less than 10 units. So the answer to the question that X, the value of line segment X, is equal to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. We finished with the first method, then I presented to you how to find out the value of line segment X according to the second method. In the second method, we did another construction. Here, from point D, we draw a straight line to AC in such a way that angle AEC, angle AED, this angle will be equal to 45 degrees. Okay, so angle AED equals to 45 degrees according to our construction. So here, in triangle AED, this triangle, we have two angles that are equal to each other. They are both equal to 45 degrees, and we know that in front of equal angles in the triangle there are equal sides. That is to say, in front of those two equal angles there must be equal sides. That is to say, AD must be equal to DE. AD must be equal to DE, but AD equals to X according to what is given us in the question. So from this equation, X equals to AD equals to DE, we will derive that DE is also equal to X. In the right triangle, in triangle ADE, we know that the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles in any triangle is equal to 180 degrees. So which angles we have in triangle ADE? We have 45 degrees and 45 degrees plus the missing angle that is angle ADE. In total, the sum of those three angles must be equal to 180 degrees. Here we subtracted 90 degrees from this equation, and we got that the missing angle, angle ADE, equals to 90 degrees. That is to say, triangle ADE is a right triangle. Then, here we defined angle BAD as theta. This is a right triangle, ABD is a right triangle, therefore this angle must be equal to 90 degrees minus theta. In order to complete the sum of the angles in the right triangle ABD to 180 degrees, this angle must be equal to 90 degrees minus theta. BC, line segment BC, is one side of the right triangle, triangle ABC, therefore it must be a straight line. So here, BC is a straight line, and we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Okay, so the sum of the angles on the upper side of the straight line BC at point D must be equal to 180 degrees according to the rule that I mentioned. So which angles we have on the upper side of the straight line BC at point D? We have here one angle that is equal to 90 degrees minus theta. We have this angle that is equal to 90 degrees, and we have the missing angle EDC that is that is the missing angle. So in total, the sum of those three angles must be equal to 180 degrees. I'll repeat again. At the upper side of the straight line BC at point D, the sum of the angles must be equal to 180 degrees. So we have one angle that is equal to 90 degrees minus theta, the other angle that is equal to 90 degrees, and the third angle, the missing angle EDC. In total, the sum of those three angles must be equal to 180 degrees. 90 degrees plus 90 degrees is 180 degrees. So we have 180 degrees on both sides of the equation, so 180 degrees will get cancelled. And we left only if minus theta plus angle EDC that is equal to 0. We added theta to this equation and we found out that the missing angle, this angle EDC equals to theta. Then from point E we do perpendicular on BC, so this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. So in the right triangle, triangle EFC, if this angle equals to theta, then this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles in this right triangle to 180 degrees. Then we proved that those two right triangles can go into each other according to angle side angle rule. So why those two right triangles can go into each other? First of all, those two angles are both equal to theta, they are equal to each other. Those two angles, they are both equal to 90 degrees minus theta, and we have side AD that is equal to side DE, and it equals to x. Both those two sides are equal to x. So we proved that two angles and the side between them in this triangle ABD corresponding congruent to two angles and the side between them in triangle DEF. Therefore we prove that those two right triangles can go into each other according to angle side angle rule. And from the fact that those two right triangles can go into each other, we conclude that AB equals to DF according to the rule that corresponding sides in congruent triangles are equal to each other. AB equals to DF, but AB equals to 6 according to what is given as the equation. So from this equation, 6 equals to AB equals to DF, we will derive that DF is also equals to 6. DF equals to 6. So if DF equals to 6, what is the value of DC? It is very easy to see. What is the value of FC? It is very easy to see that DC minus DF equals to FC. Okay? Here, DC minus DF equals to FC. DC equals to 10 units, DF equals to 6, so FC equals to 10 minus 6, that is 4. So we found out that here FC equals to 4 units. Likewise, because of the fact that those two right triangles can go into each other, BD must be equal to EF according to the rule that corresponding sides of congruent triangles are equal to each other. BD equals to EF. If we define BD as Y, then from this equation, Y equals to BD equals to EF, we will derive that EF is also equals to Y. Then we proved that the right triangle ABC is similar to the right small triangle, triangle EFC. Why those two triangles are similar to each other? First of all, those two angles are equal to each other, they are both equal to 90 degrees. We have a common angle that belongs to both triangles. So this angle equals to itself. And we have those two angles that are equal to each other according to third angle theorem. What is third angle theorem? Third angle theorem states that if two angles in one triangle congruent to two angles in another triangle, then the first pair of angles must also congruent. Therefore, we prove that all the angles in triangle ABC can go into all the angles in triangle EFC. Therefore, those two triangles are similar to each other. And from the fact that those two triangles are similar to each other, we conclude that AB over BC equals to EF over FC. Okay? AB over BC equals to EF over FC. AB equals to 6. BC equals to Y plus 10. EF equals to Y. And FC equals to 4. So in conclusion, we found out that Y over 6 over Y plus 10 equals to Y over 4, because multiply this equation number 1, and we found out that 6 times 4 is 24, and it is equal to Y times Y plus 10. We open the brackets on this side of equation number 1, and found out that 24 equals to Y plus Y is Y squared, Y plus 10 is 10Y. Then we subtracted 24 from this equation number 1, and we found out that according to equation number 1, we got the quadratic equation y squared plus 10y minus 24 equals to 0. This is a quadratic equation, and the general formula for quadratic equation is ax squared plus bx plus c equals to 0. A, b, and c are the coefficients of the quadratic equation, and the variable that we are looking for is x. We will find out the value of x according to the following formula: x equals to minus 6 plus x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, a equals the coefficient a equals to b equals to 10, and the coefficient c equals to minus 24, and the variable that we are looking for in our specific quadratic equation is y, so x equals to y. So we put the data inside the formula for x, and we found out the value of y because x equals to y. Y equals to minus b equals to 10, so minus b is minus 10, plus minus b squared. B equals to 10, so b squared is 10 squared, that is 100. Minus 4 times a is 1, c is minus 24. So here we have minus 4 times minus 24 is 96. 96 plus 100 is 196. So we got that y equals to minus 10 plus minus square root of 196 over 2. The square root of 196 is 14, so we found out that y equals to minus 10 plus minus 14 over 2. So here we have two solutions that are possible for y. The first solution, y1 is equal to minus 10 minus 14 over 2. Minus 10 minus 14 is minus 24. Minus 24 over 2 is minus 12. But because of the fact that y is a length of a side BD, it must be a positive number. Therefore, y cannot be equal to minus 12, that is a negative number, so this solution is an incorrect solution. We cancel this solution, and we left only with the solution, with the second solution, that y equals to minus 10 plus 12 over 2, minus 10 plus 12 is 4, 4 over 2 is 2. So I found out that y equals to 2. Then we implemented the Pythagoras theorem on this right triangle ABD. According to the Pythagoras theorem, in the right triangle ABD, the square of the hypotenuse equals to the sum of the square of the perpendiculars. That is to say, AB squared plus BD squared equals to AD squared. AB is 6, so AB squared is 36. 6 squared is 36 plus BD squared, BD is 2, so BD squared is 2 squared, this is 4. And it is equal to AD squared. AD is x, so AD squared is x squared. 36 plus 4 is 40, so we found out x squared equals to 40. We took a root out of this equation, and we found out that x equals to the square root of 40, the square root of, so x equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. We finished with the second method. In the next step, I presented to you how to find out the value of line segment x according to the third method. In the third method, we did in the third method, we defined angle BAD S. We define angle BAD as theta and side BD as y. So in the right triangle ABD, tangent theta equals to BD over AB, BD equals to y, AB equals to 6. So we found out that in the right triangle ABD, tangent theta equals to y over 6. Then in the right triangle ABC, tangent theta plus 45 degrees equals to BC over AB. BC equals to y plus 10, AB equals to 6. So in conclusion, we found out that in the right triangle ABC, tangent theta plus 45 degrees equals to y over 10, y plus 10 over 6. Y plus 10 over 6. And we have trigonometric identity for tangent theta plus 45 degrees. The trigonometric identity for tangent theta plus 45 degrees, it is equal to 1 plus tangent theta over 1 minus tangent theta. We have already found out that tangent theta equals to y over 6. So we can substitute tangent theta by y over 6 in equation number 1. First of all, we substituted tangent theta plus 45 degrees in equation number 1 by this expression. And then in this expression we substituted tangent theta by y over 6 because tangent theta equals to y over 6 according to what we have already found out. So in conclusion we found out that 1 plus tangent theta over 1 minus tangent theta according to equation number 1 equals to y plus 10 over 6. So here we substituted tangent theta by y over 6 and we got that 1 plus tangent theta, that is y over 6, equals over 1 minus tangent theta, that is y over 6, equals to y plus 10 over 6. Then we substituted 1 by 6 over 6 in order to have a common factor with y over 6 and with minus y over 6. And we got that 6 plus y over 6 over 6 minus y over 6 equals to y plus 10 over 6. Here we have 6 in the numerator and 6 in the denominator, so 6 will get cancelled. And we found out that 6 plus y over 6 minus y equals to y plus 10 over 6. Because multiplying this equation number 1, and we got that 6 times 6 plus y equals to 6 minus y times y minus 10. Plus y plus 10. Okay, here we open the brackets on both sides of the equation. 6 times 6 is 36. 6 times y is 6y. 6 times y is 6y. 6 times 10 is 60. My y minus y times y is minus y squared. And minus y times 10 is minus 10y. We have 6y on both sides of the equation number 1, so 6y will get cancelled. We are left only with 36, that is equal to 60 minus y squared minus 10y. We added y squared and 10y to this equation number 1, and we got that y squared plus 10y. Here we subtracted 36 from this equation, and we got that we subtracted 60 from this equation, and we got that 36 minus 60 is minus 24. So in conclusion, we found out that according to equation number 1, y squared plus 10y minus 24 equals to 0. And this is exactly the same quadratic equation that we had in the second method. And the solution to this quadratic equation that we already did in the second method, the first solution is y1 equals to minus 12, and the second solution is y2 equals to 2. But because of the fact that y is a length, it cannot be a negative number, therefore the solution y1 equals to minus 12 is incorrect solution. We will cancel this solution and we left only with the solution that y2 equals to 2. So here we found out that y2 equals to 2, that is to say BD equals to 2, AB equals to 6, and AD equals to x. So in this right triangle, we implemented the Pythagoras theorem. The square of the hypotenuse equals to the sum of the surfaces of the perpendiculars, that is to say AD squared equals to AB squared plus BD squared. AD equals to x, so AD squared is x squared, and it is equal to AB squared. AB is 6, so AB squared is 6 squared, that is 36, plus BD squared. BD is 2, so BD squared is 2 squared, that is 4. So in conclusion, we found out that x squared equals to 36 plus 4. 36 plus 4 is 40, so x squared equals to 40. We took out of this equation, and found out that x equals to the square root of 40. 40 is 4 times 10, and the square root of 4 is 2. So in conclusion, we found out that x, the variable that we are looking for, it is equal to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Okay? Thank you very much.